Hey,
How you doing?
fine.
Good, good. Did you work on any problems or anything, or did you do any of your own exercises?
Well, I just actually got too much homework for school. I have like four tasks and two I don't know how to say it in English, but it's yes, two as a task, but two tasks, but it worth two times. It is worth two times more than normal test.
Okay.
To be
Um,
God.
yeah, I see. Did you want to go over any of that or whatever you're working on? We
Yeah,
can
but I just realized why are all the answers at the back?
just so you can check your work.
All right.
Yeah, and yeah, we can go over that if you want to challenge. But if you want to work on your two tests or whatever you want to work on that you're working on at school, we can do that. Whatever you want to focus on.
No, I just spent the whole day revising. I mean, it should be done.
Oh, okay.
Done by now.
All right. So you're okay with your two tests then?
Yeah.
Okay. All right. Well, do you want to do you have any questions from last time?
Well, not exactly.
Okay. Did you want to go over some of the problems that were assigned, like some of these guys?
Uh,
Or did you want to do something? Because we can go back and address any things that are easy from here, if you want. Or like last time we talked about consecutive integers and how to write algebraic equations from them. I don't know if you want to, we can do that if you want.
yeah.
It's up to you.
I mean, why not try?
Okay. But I will say, don't be discouraged because this question that you asked me to show you a little bit about last time, this is the hardest one out of all the ones that I've seen and I've seen the first half of the problems. So this is the hardest one. So don't be discouraged if you find this one hard to understand, you know.
Well,
This is
someone explained me that actually I got to look to the two final numbers. Like there's a seven and a seven. So and 77 is the only one who's actually you actually can't divide by seven, so it's actually number eight.
yeah, exactly. So it's because it keeps repeating. Right? If you do
Mm.
seven to the first, seven to the second, seven to the third, seven to the fourth, and then you keep doing that, you see a repeating pattern. And then and then you divide four into 2017, and you get a remainder of one, so that's how you get the seven. But and I can show you the rest of it if you're interested. But that's a harder one or
Mm.
a more difficult one. So but I can quiz you on some stuff.
Yeah, why not?
Okay. Um, let's do let's do this. Okay, so if m is an in if m is a counting number and z equals 7m,
Okay.
what is z divisible by?
Seven?
Yeah, exactly. And so that makes sense to you, right?
Right.
Yeah. So you understood that other problem that we did last time, right? With where the answer was 975.
Yeah.
You understood that? Okay. Let's see. So here's a good one that uses kind of like algebra, I guess. Let's see. Like this one, for example.
Yeah.
This one uses it's just algebra. Try this.
Yeah.
All right, so you want to try this one? Question 8.
Let me think. N and B have together have 110. Oh, B and yeah. So N and C together have $70. How much would they have in total? So inside this one has 30. I can't find. I can't find. No, I can't find the answer.
Oh, okay. All right, so can you write an expression for the answer they are asking for? So if we write N equals A, right?
Yeah.
Uh, B Beatty equals B and
Mm-hmm.
Steele equals C.
Yeah.
Can you write an expression in terms of A, B, and C for the answer they're asking for?
So we must. So do you want to know how much money do we have if ABC had all the money together?
Exactly. And so what would the expression be for that?
Uh, A plus B plus C.
Correct. A plus B plus C. Exactly. So for a lot of these problems and for a lot of problems that you're going to see at university, you just start writing equations for things that you know and things that you don't know, and you find how many knowns you have and how many unknowns you have, and then you just see what you're working with. So can you write an equation for the first part of the first for this sentence here? Ann and Beatty together have $120.
But how do I find if I split 60 and 60 together it will be impossible.
Yeah, so maybe we can find something that's like a sum of everything, right? So Adam Beatty, so A plus B equals 120, right?
Right.
And we also have what's the second equation, or what's the second equation going to be for this sentence? Beatty and Cecile together have 60, right?
Let me think. I could say something like 50 and 10 maybe.
Well, we don't know, but we can write an equation, right? So like we can just write B plus C equals 60, right? Does that
Is
make
it
sense?
is it possible for someone to actually have $0 or only five?
Yeah, anything is possible. Yeah. Yeah, they could have like B could have 0 and C could be 60, right?
Yeah.
So that's possible. So we're going to cover all the bases by just writing out all the equations and seeing if we can solve it, right?
Right.
So what's the third equation going to be?
A plus C equals 70.
Yeah, A plus C equals 70. So this is continuous. You're trying to do something like you're trying to do integer programming, but this is continuous. Like they could have $31.6667, right? Or something like that, right?
Yeah.
So what happens if we add all these three equations together?
Well, it will actually end up with 250.
Yeah, so it's going to be 250 equals, and so how do we add these variables together?
You can actually put in a, how we say, like,
Combining like terms?
no, when you, how say,
Oh, sum?
no,
Because we could just list it out, right? We could say A plus B plus C plus A plus C, right? Just add up everything.
I want to put A and B, like, how say, like, there's the thing that looks like half a circle.
The semicircle?
Yeah, you can put actually A and B together inside it.
Yeah, but it's even easier if we combine. Oh, you mean parenthesis? Yeah, exactly. So you could do this, right? A plus B.
Yeah, right, this one.
Yeah, B plus C, and then plus A plus C. And then, so does that make sense that this equation right here?
Yeah.
Okay. And then now, so now that we have this, what should we do? Now we can combine like terms, right?
Yeah.
So if we wanted to combine the A plus the A right here, right?
Okay.
Like what do we get when we get A plus A?
A plus, well,
A plus A.
A plus A. Well, I can actually find what A could be.
Well, we could just say how many A's we have, right?
You got two.
Yeah, two A's. Exactly. So we could say two A's,
Right.
2A plus how many B?
Um, two B's,
2B plus how many C?
two C's.
2C. And do you see this in terms of the original expression that we were looking for? Because we were originally looking for a plus b plus c, right?
Right.
So now we have, can you turn this into a plus b plus c?
Working to like AA plus BB plus CC?
Well, it's 2a plus 2b plus 2c, but you're right. We could probably factor out the 2, right?
Mm.
Make it a plus b plus c.
Mm.
So the equation that we have is 2 times the answer that we're looking for is equal to 250.
Oh, so we must divide it by 2 then.
Yeah, exactly.
So that means could possibly be number B.
Yeah, exactly. If we divide 250 by 2, we get 125, and therefore we have a plus b plus c, which is the answer that we were looking for, right?
Right.
The answer.
Okay.
Because we were looking for a plus b plus c. So you see, we didn't have to know the individual guys. We still don't know how much each individual has, right? But we know
Right.
that they sum to 125. So we still don't know how much each one has, but we know how much they all add up to. So there are things that you can. So what we take from this is that there are things that you can do with sums that you can't necessarily do with each solving for each individual variable.
Okay.
Yeah. And I just like to denote Z as the answer just so that we can keep track and remember that we're remember to go back and look for what they're asking for, right?
Right.
You don't have to call it Z if you don't want, but that's I tend to do that just to make it clear that that's the answer, right? But always keep checking back for the problem, for the prompt to see what they're actually asking for, right?
Right.
So do you have any questions about that?
No, not exactly.
Okay. All right. And then let's see, there might be another algebra, or this is kind of an algebra problem if you want to try this. But let
Yeah.
me let me show you. Oh, or do you want to do question 10 or try it?
What?
Hello, can you hear me?
Yeah.
You want to try to do question 10?
Oh yeah, question 10. Yeah,
Yeah, it's an algebra problem.
I heard question. I heard question time. I said, what's
Oh,
that?
question time. Okay.
Yeah.
So let's try this. Okay, so look at this one and let me know what concept from algebra you recognize here that you would have to use in order to do this. And if you don't recognize one, I can show you what the concept is, and you can work with it. We can work with that concept. I'm not sure if you've seen it yet. I don't remember when I learned it.
Yeah. So logically, we need the answer of 4 times 2017 minus 4 times 2016.
Um, that might be true. How do you know that, or what makes you think that?
Because there's a small four, so we must do 2017 times 2017, like 4 times. 2017 times 2017 times 2017.
Yeah, that's a good way of thinking about it, and I can let you explore that avenue on your own. But
Yeah.
I'll show you. Have you ever heard of difference of sometimes they call it perfect squares?
No, I didn't heard that.
Okay, so difference of perfect squares is that a plus b
Yeah.
times a minus b is
Okay.
equal to a squared minus b squared. So if you ever see anything that's something squared minus something squared, see that's a difference See, subtraction, right? Difference of squares, right? Both of these are squared.
Right.
And then you can factor it into a plus b times a minus b.
Okay.
So looking at this, so let's just do an example. Let's do if you had x squared minus 4. Okay, what would that factor to?
That will factor, let me think. X. What is X already?
It's just part of the expression. You can we don't this is not actually part of this problem. This is just a side example.
Oh, okay. So X times 2 minus 4. I mean, something that should be over 4, so it would be actually a positive number, I guess.
Yeah, it doesn't have to be a positive number, but yeah, it's so how would we recognize this as the difference of squares?
Well, I think it's actually do 2017 times 2017 times 2017 times 2017 minus, and repeat the same thing for 2016, underline at 2017 times 2017,
Okay.
then 2016 times 2016 that you at the board, just then, I guess, calculated the rest, I guess.
Yeah. Yeah, let's do that. So so the top is going to be like this, right?
Right.
So this is the numerator.
Okay.
So how can we do the numerator like this in terms of difference of squares? So we have it like we have it kind of like this, right?
I guess we can actually do 2017 times 2017. We can calculate that, and then you do the answer of 2017 times 2017. Just put the answer of that times the answer of the other side.
Did you say to do the exponent?
So you see 2017 times 2017. Yeah, then you put the times, and then you do another 2017 times 2017.
Okay. And then minus?
Minus 2016 times 2016, and then the same for the square. Yep.
Yeah. And then so that's good. Yeah, exactly. And so that's a difference of squares, right?
Right.
And so then we can get it to factor. And how do we say that how do we say it's going to factor?
We can actually use a paper to calculate.
So we can do well, let's just leave it like it is so that we don't so that we can see if anything cancels. But how do we make it look like a plus b times a minus b?
Yeah. So how do we do?
Because this is actually squared, right?
Right.
It's 2017 squared, right?
Right.
So notice how the a here is not squared. This a is squared, right?
Right.
So we could leave it as the not squared one, right?
Okay.
And then well let's just call it because it's squared, but it's not squared, right? So it's gonna be 2017 squared plus 2016 squared times 2017 squared or sorry, I forgot what we're doing. Oh, 2017 squared minus 2016 squared.
Yeah.
Does that kind of make sense?
It does.
Like we're just putting it from the right side to the left-hand side. A plus B times A minus B.
Yeah.
Right? And then you see how this can cancel with the denominator?
No.
So this one right here, this guy right here is the denominator, right?
Right.
So that cancels out, and then we're left with just this right here, right?
Okay.
Uh, okay, so we're left with this right here,
Yeah.
and so that's a squared minus b squared, right?
Right.
Which equals how do we factor difference of perfect squares or difference of squares?
Can you repeat, please?
How do we factor the difference of squares?
I don't know.
It's going to be this right here, right?
Yeah.
So a plus b times a minus b.
Mm-hmm.
So how does 2017 squared minus 2016 squared factor?
I don't know.
See, it's going to be 2017 plus 2016, right?
Okay.
And then times 2017 minus 2016,
Okay.
right? Because of the difference of squares. Because these guys were squared, right?
Right.
So we get rid of the squares and we do plus and then a minus, right?
Right.
Do
Yeah.
you see how we get that? Because if we FOIL, like last time I showed you, if we FOIL this, we get a squared minus b squared, right? Because
Okay.
if you do 2017 times 2017, right? And then if you do 2017 times 2016, and then 2016 times 2017, and then 2016 times 2016,
Yeah.
you always get, so you do that. The foil means first outside, inside, last, right?
Okay.
First, outsides, insides, lasts. And then you're going to get a squared minus b squared.
Okay.
Uh, and so do you see how we got here?
Yeah.
Okay. And then what's 2017 minus 2016?
1,
Yeah. And then so the answer is just going to be
0.
2017 plus 2016,
Mm.
right? Because it's
Times
one,
1.
because it's one times that, right?
Right.
So that equals one times this, which is just itself, right?
Yeah. I think I found the answer. Is
Oh,
it 4033?
yeah, yeah, exactly. Very good. So 4,033, right? Because that's just adding these guys up. So you see how this like really hairy expression simplifies down to 2017 plus 2016, which is just 4,033.
Yeah.
Yeah, cool. So do you have any questions about the difference of squares and how we use it?
No.
Okay. Cool. All right, let's try question 9, because that's
Hmm.
also algebra.
It seems a lot easier.
Yeah, this one will be a little bit easier. So let's see. Let's insert this. I'm just using an old. I'm gonna write over it.
2 times 2. It's actually easy. It's like you do 4 times 7.
It's not 4 times 7. It's
Times 4 times 4
four
times.
times 4, like 7 times, kind of.
Yeah. Hmm. Let me. Can I use a book? Can I use like paper?
Yeah. Go ahead and use paper.
Yeah. Thanks. Oh, it doesn't work. Let me just. It looks a lot harder than what I thought. Hmm. So let me see. 66. 4, 4, 6, 16, then 600. Okay, so actually does 264 times 4 now. Now if you actually add that again, which actually does now us, it does 1056 maybe. Times 4, so 2024. No, actually another times 4, the last times 4. This one's hard. I can't do it mentally. I should probably do it. I should probably pose it. No. Hmm. 4 total 4 times 4. Alright, 4 times 4 16. 4 times 2 8 9. 4 times 4 8. 4 times 4 16. Alright, found the answer.
Okay, what is it?
So 4 and 7. So 4 7 is 1608.96.
Okay.
And logically, and for the 2 out of 4, it's actually 16.
Yeah, 2 to the 4th. Yeah, 16. Yeah.
So if we do 16, 8, 9, 6 times 16 now, that should probably add up to, wait, let me calculate that. 36. 6 times 9, 54, 57. 6 times 8, 48, 53, I guess. 53. 6 times 8, 41. All right, so it does 10,000, no, 101,476, which
Did you
I
just do
could,
that? Did you just do that on paper?
yeah,
Wow, that's a big number.
yeah, I should have calculated all that. Just that, that's done.
Oh, nice. Okay, well, is there a way that you can factor them out to get factor them out into like a bunch of twos.
Well, I actually found a moment when it said 407. I found it was actually 16,000, and if mine is 101,000. So it could actually, if I guess correctly, it could actually approximately be 8 to 40.
No, that's not the answer, but that's a good way of estimating it. Yeah. But a faster way is, can you turn four to the seventh into two to the something?
Should do something. Let me think. It will be actually pretty long.
So let me ask you, what is two squared and in parentheses squared?
Can you write it down, please?
Yeah, let me go to the Zite real quick. So it's just if you take an exponent to an exponent, right?
Right.
So just as an example, right? Two cubed, for example. Let's just say
Oh,
two
yeah.
cubed. I
So
changed it
I
on you.
guess 8. Oh,
Yeah,
wait,
two
wait.
cubed is eight. Yeah, that's right. But let's say so two cubed is actually or two cubed squared, right, is actually two of these, right?
Yeah, it's actually 64.
Yeah, it's two yeah, exactly. It's 64. But it's two of these, right?
Yeah.
So what we see is that we multiply the exponent by the other exponent.
Yeah, 8 times 8,
Yeah,
64.
exactly. Yeah, it's 64. So it's gonna be two to the sixth, right?
Yeah.
So what we see is that if we have uh a to the b to the c, right? What's that gonna be in terms? It's gonna be a to the what?
What is A? Oh, yeah, all right. A is 2, B is 3, and C is 2.
Yeah. So in general, when we work with exponents, if we have some base to a power to another power, what do
Yeah.
we do? What do we do to these power? What do we do to these exponents?
I guess we multiply it and do 2 out of 6.
Yeah, we multiply. We do a to the b c, right?
Yeah, 6.
Yeah, exactly. So if we have yeah, let me see. So if we have four to the seventh, right? Can
Yeah.
I change that into two squared, right, to the seventh, right?
Yeah.
Which is equal to two to the what?
2 to the 14th.
Yeah, very good. Two to the 14th. So we have two to the 14th times two to the fourth.
2 to the 4th, but to actually add the 10. So 2 to the 4th, I actually guessed it. That was actually 16.
Yeah, that's
But
16. But if we break it down, oh, go
if
ahead.
we if we do the same with 10, let me calculate that. 2 times 4 gets to 4, 8, 10. So wait, no, I just remember that actually 2 of 6. Yeah. How dumb can I be? 64, 6 more times 228, 7. 8 will be 250, 6. Yeah. No, it will be eventually 512 and 10, 1024. So I guess we can say that it's it's very long. 11,
So
2.
so if we can change these twos into eights, then we can find the answer, right?
Right?
But the two, so this is about 14 twos multiplied by each other, right?
Right?
And this is four twos being multiplied by each other. So how many twos in total do we have being multiplied by each other? Right? Because there's 14 twos on the left and there's four twos on the right, right?
Just
So it's 14 plus four is
Oh, wait.
18.
I just found the answer.
Oh, yeah.
Is it 16404?
Uh, well, so it's going to be, so you're going to want to do it like this, right? Because you're not supposed to use the calculator, so it's faster.
No, I just used the paper.
Yeah. But this is still faster because you can, see, you can change this base 2 to a base 8,
It's
right?
for us.
Because what we said was if, because we know that the answer, we know that the answer is in terms of base 8, right?
Yeah, so it's actually
So
18.
we're gonna want it like a 2 to the third, like you said, right?
Right.
2 to the third to the what?
To the six.
To the sixth, exactly. So it's gonna be 8 to the
So it would actually be 8 times. Oh, so 8 out of 6.
8 to the sixth, right? Because this 2 to the third is 8.
Yeah, so it 8 to the 6th power.
Yeah, 8 to the sixth power. So this is the answer
It's
that we
B.
get. Yeah, exactly. See, that way's faster because then you just like work with the exponents, right?
Yeah, let me just write down the so record the answer that we just did. 10, 10 from all right.
Do you have any questions about that?
No.
Okay. Let's see. Uh, this one you can do. It's similar to what we did with A plus B plus C. Try number 12.
Oh, let me see. So if A1 plus A2 equals 1, so A2 plus A3 equals 2, A3 equals 3, A4. All right. So A51 plus the sum of 1. What? So they're asking me to do. Oh, it is actually is actually. Wait, no, it's actually not at all. A 1 plus 2 plus 3. Oh, I get what they asked me. So they're actually asking me 1 plus 2 plus 3 plus 4 plus 5 plus 6 7 plus 8 and goes all the way to plus 51.
Yeah, exactly.
No, it'll
Or
be like,
plus 50. Yeah, plus 51. Exactly.
it took me all the whole page, but I can actually work this out.
Yeah, but try to find a yeah, exactly. But try to find you probably won't need to write it all. You probably won't need to actually write it all out. There's you can find a shortcut if we add the sum from 1 through 50. But uh yeah, so exactly, you're right. So we're doing the sum from k equals 1 through I guess 51, right?
Yeah, so
Okay.
yeah, yeah,
So this is actually 1 plus, so if we go to the end, it would be 51, right?
right,
Right? Plus 2 plus 50, right?
right. I guess.
Right? If we take the second one and the second to the last one,
Yeah,
it's 2 plus 50, right?
right,
Like if we go backwards, because we did 51, we did 50 right here, we did 1 right here and 2 right here. So what's the next one going to be? 3?
3, 4, 5, 6, 7, 8,
Well,
9.
3 and what's over here?
Where?
What's what comes before the 50?
49,
Yeah, 49. So it's 3 plus 49, right?
right?
You see how these are grouping together?
Yeah.
So all of these guys are always going to add up to what?
They're going to add up to
Or each one of these. each one of these is going to be the same, right?
Oh, right. Wait, so 1 plus 4. All right.
So and then you just have to count the number of times that this happens. But see, it only goes for half of them, right?
Oh,
Because
no.
we've already cut off the right half by
Yeah.
grouping it by putting them together.
Actually, let me think. Uh, so far I'm at plus 20. So if we put 1 plus 2 plus 3 continued by times 20, we add up with 210. And I'm still continuing. It actually takes a lot of time, but it's hard. It's easy and but takes too much time.
Yeah. So if you try it this way with see everything adds up to 52, right? 50
Uh,
plus 2 is 52. 49 plus 3 is 52.
yeah.
If you do 4 plus 48,
Mm-hmm.
you see that we're just grouping up these guys like this, right?
Right. Oh, it's never gonna end. Wait. I actually got an idea. You know, we finished at A51, right?
Yeah.
Well, I'm actually at 25. It's actually 375. So if I actually add up to everything, we could end up with so the most logical answer to here would be near between A and E.
Uh yeah, exactly. So so but you see that how this is 52. So this is going to be what 50 52 times half of them, right? Which is going to be something like 26 over 2.
Yeah. I think I got
Or,
something wrong over here. Because I don't know how, but it eventually ended up with hmm, I'm already plus 28, and I'm already at 404. That should not be logical.
so
Because if we actually
the
add up to 41, the answer will mostly be C, but I think it's mostly A and E.
so what we had was A1
Right,
plus A2,
right,
A2 plus A3,
yeah,
A3 plus A4,
yeah,
and we kept going, right?
right.
And for the last one, we did A51 plus A1.
Mm-hmm.
So how many of each one do we have?
I can't find it. So, so we actually, I don't think it's possible that if we do so 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and we continue to plus 51. I think we mostly end up by C and B or B.
Okay, so but see, we got this A1 here and this A1 here, right?
Yeah,
That's two A1, right? And we've got A2 plus A2, which is two A2.
yeah.
We got A3 plus A3, which is two A3.
Mm-hmm.
So it's basically just this times two, right?
Right.
So it's two times this is equal to the sum from k equals 1 through 51 of k.
Mm-hmm. Well, actually, right now, I guess so far, I'm actually at plus 36, and already at 631.
Yeah, so when we add them all up, we're going to divide by, I think we're going to divide by 2 afterwards.
Oh, gonna divide it by two.
Yeah.
I guess, all right. But
So, because
why? But
they're
why?
asking for just the sum.
Yeah, but
They're just asking for this one, right?
yeah, but why do you have to divide, divide? Oh, why do we actually have to do it like divide by two? How is it? Oh,
Because we have two of each of these A's, right? Each of
right,
these A's appear twice.
all right,
So if we add them all up, we get double of everything, right?
yeah,
We get double of the sum from A1 through A50, which is
yeah.
this. So whatever the sum is, that's what we're looking for. This is actually the 2 times the answer that we're looking for. This is 2z.
Oh, so that's why we actually had to divide it by two.
Yeah, after you add them all up, yeah. But see, you can find a faster way if you group them together, like first and last, and second and second to last. Like you can just multiply then, right?
Wait, let me. Wait, I finished now. I ended up with 1,426. If we divide by two, I think we should end up but with 663.
Oh, okay. Um, let's see. So this is going to be. Let me just check. So if we did this, it would be 52 times something like what 20, 25 or 26. So it's going to be like 12. Yeah, yeah, exactly. It's gonna exactly. That's the answer. Yeah.
Yeah,
So yeah, so if you divide by 2, you get your 663, right? Or
right.
663 or 60. It's either A or E, I'm not sure. But yeah, do you get exactly 663?
Uh, yeah,
Okay, cool. And you see how there's a faster way, right? If you group them like this, because then it would be something like 52 times like 26, right?
right.
25 or 26 or whatever,
Yeah,
right? Because you only have to multiply by half of them because this happens something like half of 51 times, right?
right.
So, and that's equal to 2z,
Yeah,
or, and so z is equal to half of that. So it's something like 52, 52 times 13 or 4, something like that, right?
yeah. And the funny
Because it's
thing,
faster to multiply, right?
right? And actually, the most funny thing is when actually I had arrived at plus 43. The answer is actually 911.
Oh, really?
Yeah.
That's funny. Yeah, that's crazy. Yeah, you see a lot of weird stuff in numbers that just happen to be like that. You
I
know,
guess.
yeah. Uh, yeah, and that's the subject of numerology, but you could totally study like the probability of these things being coincidences.
Yeah.
Uh, and
More
there's a little bit of
coincidence.
probability in this sample sheet as well.
Yeah.
Yeah. So, do you have any questions about this?
No.
Oh, okay. Um, let's see. So, uh, yeah, so there's a closed form solution, just so you know.
What?
Closed form. There's a closed form solution
Oh, close.
to the sum of the first k terms.
Yeah.
Uh, so let's see. So you can like look at some of these. some of these solutions if you want to make it faster. But you'll
Oh,
eventually have to learn these in high school. But
we'll
it's
learn in
easier.
high school.
What's that?
We'll actually learn that in high school, huh?
Oh, you probably will. Yeah, learn it. Well, I don't know. Maybe you've already learned some of these, uh, but if you haven't learned them yet, you probably will have to learn some of these in high school. These are uh, just ways to add things up faster by multiplying instead of just adding up each individual one, because you might have like 3,000 add up, right? It's faster to do it with a closed form solution than adding it up 3,000, actually 3,000 times, right?
Right.
So you might be able to play with some of these, but this is one of them that we just did, that you did by hand is finding out, the first 51 consecutive numbers, the sum of them, right? This is the sum of the first 51 consecutive numbers, right? So there's a closed form solution which is similar, something like this: 52 times like half of them, right? Half of 51 or whatever, or half of 50.
Mhm.
So you can work with some of those if you want.
All right.
Yeah, and so are you finding the homework problems too challenging or not challenging enough or just right?
Uh, I mean, some too easy. It would be never too easy for me, but I mean, some of them I could actually do it if I take some time, and some of them could be maybe too much challenging for me to understand.
Yeah, well, these are those problems are supposed to be challenging. So if you find them challenging, that's exactly what they're supposed to be.
Yeah.
So I don't think anyone just looks at it and goes, "Oh, this is simple." I don't think anyone just looks at it and goes and just knows the answer right away, right?
Yeah.
So it's supposed to be challenging, but you can see that most of these problems can be broken down into simpler problems that require elementary principles
Yeah.
and then so most of this can be simplified. They don't actually take a long time once you find a elegant solution, right? Once you find an elegant solution, you can do it within 5 or 10 minutes, right? So or
Right.
faster, or even faster. It just takes a long time to find a solution, right? So, but the point is to be thinking about it as much as possible and see if you like thinking about it, right? Because that's what the mathematics is as a profession, right?
All right.
Yeah. Okay. Let's see. Uh, yeah. So if you don't have, yeah, do you have any other questions, or did you want to?
Wait, it's already 58?
Yeah, yeah. Time flies when you're having fun, right?
Yeah.
Yeah. See, it shows you like it. You like math.
Especially when I actually had to use the whole paper just for this exercise.
Yeah, yeah, yeah. That's crazy that you added them up so fast, though. I I wouldn't be able to do it that fast.
I mean, it's just 1 plus 2 plus 3, 6, plus 4 plus 5 plus 6, 15, plus 7 plus 8 plus 9 is 24. You add 6 plus 15 plus 24. It actually does 45. Just continue.
Oh, okay. Wow, that's interesting. Is there a repeating pattern?
Yeah.
Oh, okay.
No, and then when you finish at 51, you should be done quicker than actually expected. Then if
Yeah,
you do
yeah, for sure. Cool, cool.
it's like a pyramid.
Yeah, exactly. It's just like a pyramid. Exactly. That greatly simplifies things,
Yeah.
right? Because then you could just multiply by like 25 or 26, right?
Mm-hmm.
Yeah. So, all right. If you don't have any other questions, I guess we'll just meet same time next week.
Yeah.
All right. Thank you so much. Keep working hard.
Yeah. Thanks. Bye.
Talk to you later. Bye.
Bye.